Y parameter of two-port circuit. In this two-port network, on the left hand side we have input port and on the right hand side we have output port. Equations for Y parameters are I1 equal to Y11 V1 plus Y12 V2. This is equation 1. Second equation is I2 equal to Y21 V1 plus Y22 V2. This is second equation. We can write these two equations in matrix form. On the left hand side we have currents and then this matrix Y11, Y12, Y21, Y22 and then the voltages. This matrix is called Y matrix. It is also called short circuited admittance matrix because the Y parameter is also called short circuited admittance parameter. Now Y11 is I1 over V1 when V2 is 0. Its unit is mho. It is called input admittance because it is the ratio of current to voltage of input port when the output port is short circuited. Then Y12 is I1 over V2 when V1 is 0. It is called reverse transfer admittance because it is the ratio of current of input port to voltage of output port when input port is short circuited. Here admittance is transferring from output port to input port. Hence it is called reverse transfer admittance. Now Y21 is the ratio of I2 to V1 when V2 is 0 and its unit is mho. It is called forward transfer admittance because it is the ratio of current of output port to the voltage of input port when the output port is short circuited. Here admittance is transferring from input port to output port. That's why it is called forward transfer admittance. Now Y22 is the ratio of I2 to V2 when V1 is 0. It is called output admittance because it is the ratio of current to voltage of output port. Now this is third equation. We can represent this equation in this form. This column matrix is represented by I, the Y matrix is represented by capital Y and the voltage matrix is V. Now if I multiply both sides with inverse of Y matrix, then it is inverse Y into V, and inverse of Y into Y is identity matrix and identity matrix into V is V. So it is V equal to Y inverse I, or we can write V equal to Y inverse I. Now in the previous lecture we have discussed about the Z matrix and V equal to Zi. In the we can write the equations of Z parameter in this form: V equal to Zi, where Z is the impedance matrix. So if I compare these two equations, then I can write Z matrix equal to inverse of Y matrix, or Y matrix is inverse of Z matrix. So let's do this conversion first. Z matrix is inverse of my Y matrix. So Z matrix is Z11, Z12, Z21, Z22. That is equal to inverse of y11, y12, y21, y22. So how to find out the inverse? Inverse, this is 2 cross 2 matrix. So 1 by determinant of this Y matrix, which is y11, y22 minus y12, y21, and then adjoint of this matrix. So for to find the adjoint of 2 cross 2 matrix, we will simply interchange this diagonal. This will be y22, y11, and we will make the sign changes of these two elements. So minus y12 and minus y21. The determinant of this Y matrix is denoted by del Y. So this is the inverse of Y matrix. So this is the conversion. It means Z11 is Y22 over del Y, and Z12 is minus Y12 over del Y. Z21 is minus y21 over del y, and z22 is y11 over del y. So this is the conversion of y parameters. So in fact, yes, z parameters in terms of y parameters. Now we can make the another conversion also, where y is equal to z inverse. So y11, y12, y21, y22 is equal to inverse of z11, z12, z21, z22, and the inverse is 1 by determinant of this z matrix, and then adjoint, which is z22, z11, and then minus z12 minus z21. So we can write y11 as z22 over del z. y12 is minus z12 over del z. Del z is determinant of that matrix, and y21 is minus z21 over del z, and y22 is z11 over del z. So in this way we can write y parameters in terms of z parameters. Now let's see the y parameters of a few circuits. This is the two-port network, and it has just one impedance. The voltage of port 1 is V1, current is I1. Voltage of port 2 is V2, current is I2. Now we have to find out the Y parameter for this two-port network. From the circuit we can see that V1 is equal to V2, and yes, in this Y parameter here, V1 and V2 are independent. V1 and V2 has to be independent. So here in this circuit, V1 and V2 are dependent. So V1 and V2 are not independent. Hence, Y parameter for this circuit does not exist. Okay, because V1 and V2 are dependent. Now let's take another circuit. In this circuit, again we have just one impedance. and we have to find out the y parameter. So in the circuit, I1 is equal to minus I2. Okay. Now let's apply the KVL. Rise in voltage V1 equal to, in fact, rise in voltage V1, then drop across Z, which is ZI1, and then drop V2. So ZI1 is basically V1 minus V2, or I1 is 1 over Z V1 minus 1 over Z V2. This is the first equation. And since I1 is minus I2, I2 is minus of I1. So I2 is equal to minus 1 over Z V1 plus 1 over Z V2. This is the second equation. So from these two equations, we can write Y matrix as 1 by Z minus 1 by Z, then minus 1 by Z and 1 by Z. One more thing, we have a reciprocal two-port network. Reciprocal two-port network or circuit. Condition for reciprocal two-port network or two-port circuit is V1 over I2 when I1 is 0 must be equal to V2 over I1 when I2 is 0, or in terms of Z parameter, the condition for reciprocal two-port network is Z12 must be equal to Z21. And from the we have the expression for Z parameters in terms of Y parameter. So this Z12 is minus Y12 over del Y, and Z21 is minus Y21 over del Y. So this will give Y12 is equal to Y21. So this is the condition for reciprocal two-port circuit in terms of Y parameter, and the condition is Y12 must be equal to Y21. Now we have symmetrical two-port network. Symmetrical two-port network or circuit. Condition for symmetrical two-port network is V1 over I1 when I2 is 0 must be equal to V2 over I2 when I1 is 0, or condition for symmetrical two-port circuit in terms of Z parameter is Z11 must be equal to Z22. Now we can write Z parameters in terms of Y parameters. So Z11 is Y22 over del Y, and Z22 is Y11 over del Y, and this will give Y22 must be equal to Y11. So this is the condition for symmetrical two-port network in terms of Y parameter. Now we will find out the Y parameters for pi network or pi circuit. Why this circuit is called pi circuit? Because elements are connected in pi shape. We have three impedances that are connected in the shape of pi. This is port 1 and this one is port 2, and the impedances are Z1, make it, yes, ZA, ZB and ZC. So to find the Y parameter, let us apply the KCL at the node with voltage V1. KCL at V1, current entering is I1, current leaving through ZA is V1 over ZA, and current living through ZC is V1 minus V2, because voltage here is V2. This node is reference node. V1 minus V2 over ZC. So I1 is basically V1, in fact 1 over ZA plus 1 over ZC, V1 minus 1 over ZC, V2. See, ZA is impedance, so 1 over ZA is YA, admittance, and 1 over ZC is YC, admittance, and 1 over ZC is YC. So this is basically the first equation. Now apply KCL at V2. Current entering is I2. Current living through ZB is V2 over ZB. Current living through ZC is V2 minus V1 over ZC. So the I2 is minus 1 over ZC V1 plus 1 over ZB plus 1 over ZC V2, or we can write in terms of admittance, I2 is minus YC V1 plus YB plus YC into V2. This is the second equation. So I can write Y matrix as see 1 over ZA plus 1 over ZC, and then minus 1 by ZC, and then minus 1 by ZC, and Y22 is 1 over ZB plus 1 over ZC, or simply YA plus YC minus YC minus YC, and then finally YB plus YC. So that's how we find the Y parameter for the pi circuit, and the unit for all the elements has to be mho. Now let us find out the Y parameter for T network or T circuit. It's called T circuit because elements are connected in the shape of T. We have three impedances, ZA, ZB and ZC. This is port 1 and this one is port 2, and we have to find out the Y parameters. So in this circuit, basically the three elements are connected in star shape. Now first of all, we'll convert this star circuit to delta. Like this, and the three elements are Z1, Z2 and Z3. So this here Z1, I hope you know that star to delta what is star to delta conversion. I am writing it directly. This Z1 is ZA ZB plus ZB ZC, and then ZC ZA, and for Z1 denominator is ZB, and then Z2, for Z2 denominator is ZA with same numerator, ZA ZB plus ZB ZC plus ZC ZA, and for Z3 denominator is ZC with same numerator, ZA ZB plus ZB ZC plus ZC ZA. So we can redraw this circuit, which is now, after converting from star to delta, the circuit becomes pi network or pi circuit. This is Z1, Z2 and Z3, and we know that we know how to find out the Y parameter for this pi network. Y11 is 1 over Z1 plus 1 over Z3. y12 is minus 1 over z3, y21 is minus 1 over z3, and y22 is 1 over z2 plus 1 over z3. So in this way we can find the y parameter for T network. Now let us find out or the analysis of terminated two-port circuit. Terminated two-port circuit means the two-port output port is terminated at load impedance ZL. This is two-port circuit. And at input port we have external source VG with series impedance ZG. This is 1 dash, 2 dash. Voltage at port 1 is V1, current is I1. Voltage at port 2 is V2, current is I2. And here we have to find out the input impedance, input admittance YI, which is the ratio of I1 to V1, and the output admittance, which is the ratio of I2 to V2 when Vg is 0. So first of all, let us find out the input admittance. Equations for y parameter. Equation for y parameter for this two-port network are I1, Y11, V1, Y12, V2. This is first equation. Second equation is I2, Y21, V1 plus Y22, V2. This is the second equation. And we have to find out the ratio of I1 to V1. So from the first equation we have to get rid of this V2. So first of all, write the expression for V2. V2 is minus ZL I2. So I2 is basically minus V2 over ZL. Now we will substitute this I2 in equation 2. So equation 2 becomes negative V2 over ZL equal to Y21 V1 plus Y22 V2. So V2, okay, so negative V2 over ZL minus Y22 V2 equal to Y21 V1. So 1 over ZL plus Y22 is equal to into V2 is equal to minus Y21 V1, or this V2 is negative Y21 V1 over 1 over ZL plus Y22. So this is third equation, and we have to substitute this V2 in equation 1. So I1 is Y11 V1 minus Y12 into Y21 V1 over 1 over ZL plus Y22. So, okay, take V1 common and bring it to the left hand side. So Yi is I1 over V1, which is Y11 minus Y12, Y21 over 1 over ZL plus Y22. This is the expression for input admittance of this terminated two-port network. Now we have to find out the output admittance, which is the Thevenin admittance simply. So to find the output admittance first of all, let's make the generator voltage 0. So making this independent source 0. So this path is basically short circuited, and because output admittance is looking from the port 2, there is no need for load impedance. And since the two-port network has some dependent source, so to find out the admittance of that, we need to have an external source, and that external source has voltage V2 with current I2. This external source is providing V2 and the current I2. So output admittance is basically the ratio of I2 to V2. Now the equations for Y parameters are I1, Y11, V1, Y12, V2, and I2 is Y21, V1 plus Y22, V2. This is first and this is second. And we have to find out the ratio of I2 and V2. So we need to get rid of this voltage V1. So what is V1? V1 is minus ZG I1. So I can write I1 as V1, negative V1 over ZG. Now substitute this I1 in first equation. So this is negative V1 over ZG equal to Y11 V1 plus Y12 V2. Now negative V1 over ZG minus Y11 V1 equal to Y12 V2. So this V1 is basically negative Y12 V2 over 1 over ZG plus Y11. Now we will substitute this V1, this is third, substituting this V1 in equation 2. So I2 is negative Y21 into Y12 V2 over 1 over ZG plus Y11 plus Y22 V2. So Y0, which is I2 over V2 when Vg is 0, is simply Y22 minus Y21 into Y12 over 1 over Zg plus Y11. So that's how we find out the output admittance. I forgot to tell you the equivalent circuit for two-port network. So let's draw the equivalent circuit for two-port network in terms of Y parameters. The first equation is I1 equal to Y11 V1 plus Y12 V2, and the second equation is I2 equal to Y21 V1 plus Y22 V2. In this first equation, on the left hand side we have current. So the two terms on the right hand side are also currents. And the sum of current is possible when the two components are connected in parallel. So current at port 1 is I1 and voltage at port 1 is V1. So this Y11 into V1 is current through Y11. So Y11 is connected across 1 and 1 dash. This is the admittance. And the second term is also current, and the second term is having voltage V2, and V2 is the voltage of port 2. So the second term has to be a dependent source, which is a current source which is depending upon voltage of port 2. So let's make a voltage dependent current source. Its value is Y12 V2. Now, in the second equation, in left hand side we have I2, which is the current of port 2. So on the right hand side, the two terms are also current, and addition of current is possible when the two components are connected in parallel. So Y22 V2 is basically the current through Y22. So which is Y22 is connected across 2 and 2 dash. Now the first term in the second equation has the term V1. V1 is the voltage of port 1. So the first term of second equation has to be a dependent source, which is dependent current source depending upon voltage. So it is voltage dependent current source, and its value is Y21 V1. And all the impedances, all the admittances are in mho or ohm inverse. So that's how we draw the equivalent circuit for Y parameter. Now let's see few examples so that we can solve two-port circuit for Y parameter. For this two-port network, Y parameters are given, and this circuit is terminated at 100 ohm, and external source with voltage 100 volt in series with resistance 25 ohm connected at input port, and we have to find out the voltage gain, that is V2 over V1. So let us write the equations for Y parameter. I11, so in fact I1 is 0.1 V1 minus 0.01 V2. This is first equation. I2 is 0.01 V1 plus 0.1 V2. Now we have to find out V2 over V1. Okay, so we can write V2 in terms of, in fact, we can write I2 in terms of V2 from the load side. So V2 is basically minus 100 I2, or I2 is simply V2 over minus 100. Now let us substitute this I2 from 3 to equation 2. So this is V2, negative V2 over 100, that is equal to 0.01 V1 plus 0.1 V2. So this is minus 0.01 V2 minus 0.1 V2 equal to 0.01 V1. So this is negative 0.11 V2. It is equal to 0.01 V1. So V2 over V1 is 0.01, negative 0.01 over 0.11. So this is simply V2 over V1 is simply negative 1 over 11. So this is the desired voltage gain V2 over V1. For this two-port network, we have to find out the Y parameters. This circuit is looking like a pi network. Voltage at this node is V1. Voltage here is V2. Suppose this node is the reference node. So we can apply KCL at node with voltage V1. So KCL at V1, current entering is I1, current leaving through this 1 ohm resistance is V1 over 1, and then current leaving through this branch is V1 and minus 2V1 minus this node voltage V2 over 1 ohm resistance. So I1 is V1 plus V1 minus plus 2V1 minus V2. So I1 is 4V1 minus V2. This is the first equation. Now we will apply KCL at this node with voltage V2. KCL at node with voltage V2. Current entering is I2. Current leaving through this 1 ohm resistance is V2 over 1. Current leaving through this branch is V2 minus 2V1 minus V1 over 1. So I2 is minus 2V1 minus V1 is minus 3V1 plus V2 plus V2 is 2V2. This is the second equation. So I can write the Y matrix directly. Y11 is 4 mho, Y12 is minus 1 mho, Y21 is minus 3 mho, and Y22 is 2 mho. For this network, we have to find out the Y parameters. Here, 1, 1 and 1 ohm, these three resistances are connected in T shapes, and 1, 1 and 6 ohm resistance, these three resistances are connected in pi shape. So it's while solving for Y parameter, it is good to have a pi network. So let us try to convert this T network to pi first, or this star, convert this star to delta. Suppose this is, make it R1, R1, R2 and R3. So this R1 is 1 into 1 plus 1 into 1 plus 1 into 1 over this one. So R1 is basically 3 over 1, so 3 ohm. Similarly, R2 is 1 into 1, 1 into 1 plus 1 into 1 plus 1 into 1 over this one. So 3 over 1, which is 3 ohm, and R3, this R3 is 1 into 1 plus 1 into 1 plus 1 into 1 over this one. So 3 over 1 is 3 ohm. Let's rewrite this circuit. R3, this is R1, this is R2, and 6 ohm is connected in parallel with R2. This one is 1 ohm, this is in fact 3 ohm. 3 ohm, this is also 3 ohm, R2 is also 3 ohm. Now the parallel combination of 6 and 3 is 6 into 3 over 6 plus 3, which is 18 over 9 or 2 ohm. So this circuit is now reduced to exactly pi network. This one is 3 ohm, this resistance is also 3 ohm, and this one is 2 ohm. V1, I1, this is V2, I2. So the Y parameter is simply 1 over 3, Y11 is 1 over 3 plus 1 over 3, and Y12 is minus 1 over 3, Y21 is also 1 over 3, and Y22 is 1 over 2 plus 1 over 3, and the units are mho. So I can also, we can simplify this. This is 2 by 3, then minus 1 by 3, minus 1 by 3. Here the LCM of 2 and 3 is 6, and in numerator we have 3 plus 2, which is 5 moves. So that's how we find the Y parameter for the two-port network.